Good evening. Shortly, we will hear an interesting lecture by Mr. Gil Noy on online optical design and array optics simulation software tool. This is part of webinar series organized by Photonics Israel on various aspects of photonics. Photonics Israel operates within the Engineer Association as a cluster of photonics entities. Since we started operating last year, we have established close relationships with similar clusters in the US and Europe. Our mission is to deepen the knowledge in this area and to encourage cooperation both within Israel and with photonics entities in the world. We are open to your suggestions and would love to help foster new local and international collaborations. My name is Shlomo Glaser. I'm the manager of Photonics Israel. This webinar organized by OpticBB, the Berlin-Brandenburg Association, and Photonics Israel. 3D Optics is an electro-optical development company headquarters in Israel. They grow out of Femto Nano Laboratory of Tel Aviv University. Mr. Gil Noy is the CEO of 3D Optics. Mr. Noy, the stage is yours.
Hello to everyone. Thank you very much for the introduction. As you said, my name is Gil Noy. I'm the CEO of 3D Optics. Just in a few words about the company, 3D Optics is a company out of Israel. We are a spin-off from Chaim Sochovsky lab in the Tel Aviv University. We have two major product line. One is innovative optomechanics, which is excel in three-dimensional mounting. But today we are going to talk about the amazing new design and simulation software tool that we have launched in mid-May, open for the public. In this session, I'm going to go over the tool. The tool is free. You can go after this class to our homepage, 3doptics.com, register to the tool. There is a link that would get you to the tool in our website. So just register and start playing with it and start building and simulate. So without further ado, I'm going to share my screen with you. Just a second. Okay, so as I mentioned, go to 3doptics.com, and I'll follow the same step with you. You would see this blue button on top. So you would press it, and you would go directly to our homepage of the tool. Start by register, fill in your name, email, and other details. Agree to the terms and conditions and register. I'm already registered, so I'm logging in. Looking into the tool, you would find there are a few main sections here in the tool. One is the main canvas, where you would allocate all the optical elements, the optomechanics and lasers, and then where you would run the simulation. On the left side, you would find all the optomechanics components that we have in our library. You would find lasers, detectors, some isolator modulators, and some helpers. You can change this screen to close it, semi-open or fully open, so you would see different mounts here. On the top, you would see a few icons. Those are related to the design itself, like undo your last action, redo, group a few components, ungroup. You can move the screen with the right click on your mouse or use the pen hand button here. This is the rotate button, zoom in, zoom out. There are a few tools here, our measurement tools that I'll show you later on, a spectrometer tool, a camera view, which shows you where the camera is looking. And if there is data associated to your design, you'll be able to see it here. Now it's empty. Then you would see that we have here save the name of the setup. That would be save your setup in our cloud environment, and it would be accessible for you. You can change to a metric or imperial version in terms of measurement. You can generate a bill of material of everything that you have in your canvas, and you can run a simulation. On the top, you would see that you have an import or export button. It's for the design that you have done. You can either import a design that someone has sent you, or you export a design and then you would like to import it because you do not want to save it in our cloud environment. Last thing is your user settings are here. There are some settings that you can define for each and every personal environment. So we would start. I would start by placing some mounts on the digital canvas. You would see that each and every time that we open the tool, there is an optical table. You will take a mount, and those are ordered like in their size fashion, like 0.5 inch and 1 inch. So you can take a kinematic mount, place it on the canvas. Let's take another mount, which is a little bit more complex. I would also place a cage mount because I would like to show you how we are dealing with cage. And I would place, lastly, a mount that is associated with volume mount, like prisms, and some mirror mount that are volume and not thin optics. You can find more mounts in this section as well. Keep in mind that we can filter the mounts. These are what we call third party because those are the mounts that you can find from the big vendors in the market. We have our own optomechanics. I would put some of our optomechanics just to show you what is 3D optics, optomechanics all about. We start with 3D optics with boards. They have dowel pins mount locations. So when we take a mount from 3D optics, it has dowel pin beneath it. So you can see that it would be associated to the dowel pins. We will talk about this later on. In the imperial version, you can see that all mounts are snapping into the grid. This is a 0.75 inch. But since you can mount those mounts with forking clamps, you have on the right side what we call is an emerging toolbar. Each and every selected mount has its own emerging toolbars with a function that you can associate it specifically to that mount. So if this mount has those 0.75 inch jumps and you want to move the mounts inside the grid jumps, you can scroll down to the offset section, and you can see that you can change the mount inside those grid jumps. And so you'll be able to allocate it everywhere. More function on the right side. So first, it's the name. Then it's the optical element section. This is very important. With 3D optics, as opposed to all the other optical simulation software, you start today with placing optomechanics, and then you mount to the optomechanics the optical element, and then you can run the simulation. It's quite different than placing the optics and then running a simulation and then moving to a CAD software. In 3D optics, it's a mesh between CAD and optical simulation. So we start with the CAD, with the mounts, and then for each and every mount, we actually allocating the right optical element. So now we have in our database more than 25,000 optical elements from more than 15 vendors across the world. So I will do search. This mount is a 1 inch mount. So I can pick up like a mirror here, and I can filter it to pick up an off-axis parabolic one. The shape in this case would be circular, and the diameter is 1 inch. And then I can pick and choose between a lot of vendors that I have here. So let's pick up one element. So now you see that automatically the optical element is inserted to this kinematic mount. In the section of the optical element, you would see a link. If you would press that link, you would see a small widget that shows you that this is the optical element. All the factors and the data about this optical element would be written here on this page. And if you scroll all the way down, you would see that this element is specifically coming from Edman Optics. If you would press this, you would jump directly to this product page of this element or the family of this product page. So it would save you a lot of time. If you want to see the coding element for this, the coding file for this element, so you would press this button here. Okay. In this next section of this mount is the advanced optics. That specific element is an off-axis parabolic mirror, so you cannot treat it as a flat element in the simulation. If it is a dichroic mirror, for example, you would be able to treat it as flat for the sake of the simulation. If it is a lens, you can apply a no reflection, again, for the sake of the simulation. If you would like to flip the optics on the other side, this mount don't allow it. But on some other mounts and some other optic elements, you can flip it 180 degrees. This is the number of reflection. Specifically, this is the default of lambda. Typically, it's max lambda, so you will not be able to change it. In the advanced setting, if you would press it, it would allow you to customize this specific element and save it as a customized element. We would allow you to change some of the parameters, not all of them. In this case, you would see that you can change the material. You can change the height of this element. If you don't know what's the height, you can get it from here. So that is the height here. Back to the widget. So let's change the height. So you'd see that automatically the height is changing. So I'm changing this. And you can change the inner and outer radius output. So let's save this. So now automatically you see that this optical element, the customized one, is already inserted. Once it is inserted, let's move forward with the toolbar on the right side. Since we entered an optic, so automatically in the part label, you would get the name of the optics, and you can display it above the mount. You can also customize it and call it whatever you want, like call it off-axis and update, and you can see here off-axis. Next section is the orientation section. You can either change the mount orientation, or you can enter a certain degrees. Let's move it back. Next, you would see the height. Now it is mounted on the breadboard, but you can take it up or down because sometimes you want to do three-dimensional setup. In the pose settings, you can take it up and down, very similar to what you can do in the lab. You can change the pose to a 3D optics pose that would provide you the ability to take it and to place it on the 3D optics breadboard and enjoy the dull pin mechanism in terms of alignment processes. But let's get it back. Since this is a kinematic mount and it has two knobs, it means that it allows you to change the degrees of freedom. So in the optical element delta, you would see only the available degrees of freedom that that specific mount provides. So if you would see that when I'm changing the degrees of freedom, and this mount allows up to 4 degrees, the orientation of the optical element is changing, and that would reflect the simulation. So let's reset that. And that's it about this mount. Let's talk a little bit about this mount. This mount, and let's put here on this mount a mirror. Let's put here a dichroid. This mount has 6 degrees of freedom. So in the optical element delta, you would see all of the degrees of freedom are available to this mount. Let us look from the side, because in this mount, when I move the degrees of freedom, you would see that here you would see that it is changing according, like the entire surface here is changing according to the degrees of freedom that we provide. The degrees of freedom that you don't see are actually here in the center, like the X and the Y and the Z. So this is the mount that has 6 degrees of freedom. This mount, and this mount as well, allows you to add accessories. So accessories are below the part labels. Currently, we have a few accessories. So let's talk about lens tube. So you can add the lens tube. So now you see that the lens tube is associated to this mount. If you want to add an optical element in the lens tube, you need to press it. You would see that it would become blue. And then in the optical element section, you need to filter for, again, for 1 inch. And you would see that the element is now inside this lens tube. If you would like to cascade additional lens tube and in each one add different optical element, that's allowed as well. So you need to press the major mount, go to accessories, filter for lens tube, and now add one, then you see that are cascaded. Again, you can delete the one that you don't want, and automatically jumps the last one to its location. Let's add more accessories. So we have other accessory. We have a lens, an iris diaphragm. So you see that automatically I'm getting an iris here. And the iris has, on the right side, iris settings, and you can open and close it according to the specification of that specific iris. So let's move it. If I would try, let's delete this. Again, major mount, accessories. I have fiber adapter. This is something that we have right now. If you would ask later on if we support fiber simulation, that would come in the next month or so. But we do have a fiber just currently for visualization. Let's delete this. Sorry. Let's go back to the accessories section. We have objective. So again, we have 2 types of objectives right now that you can place. Right now, we don't do objective simulation, and that would come in the next month or so. So currently, objectives and fiber adapters are for just for you to see as CAD and not in a simulation. Next, there is a Q beam splitter holder. We have just one of these. So this is a mount that holds a beam splitter cube. And last element that we allow here is a lens cell adapter. So this is an adapter that can hold optical element. Okay, so we have a few of these as well. So let's delete this and let's talk about cage. So very similar to the post that goes up and down, we wanted to provide the end user the ability to work with the cage. So if you would mount a cage mount, you would see that it has a cage section on the right side, and you can extract rods out of it. Once you extract rods from a mount, you would see a blue anchor hovering above it. It means that this mount is the anchor for this entire cage system. In the third-party components, you would go to cage enabled, and here you would find a few cage enabled mounts. So let's pick up one with a post. So if you select it in the post setting, you can hide the post. There are some mounts that don't have a post, and you can allocate them directly. Please notice that once you take a cage mount close to extracted rods, automatically it jumps. You see, I press the mount and mount it very closely, and automatically it jumps to those rods. Let's take this this mount as well. So once a mount is on the cage, you can move it on the grid jumps. But if you want to move it smoothly on the cage, so in the cage settings, for that specific mount, because it's not an anchor, you would not be able to extract rods, but you would be able to move it smoothly on the rods. That specific mount has kinematic capabilities, and you will be able to work with them here in this section once you have either an accessory in this mount, like if you put a lens tube. So now it has a lens tube, and you can work with the optical element deltas, or it has an optical element inside. This mount that is mounted just to two rods, you would be able that you can change the orientation on the cage. So if you change the Z, you would see that it is moving between each and every two rods. And it's more important if you use this element, the 45 degrees mount, when you want to move it like this, or you want to change it 180 degrees and work like this. So those are available on the cage mount. On this mount, that allows you to change the orientation of the mount itself. Let's put here, an optical element. So there is, on the orientation button, there is a section which we call subpart rotation. And either by pressing the Y button, you see that it is moving, or you can directly write the angle that you want to change. So this is a cage system. I didn't mention about those four arrow buttons. Those would allow you to move the mounts without your mouse and dragging it across the mouse. So just play with those arrow buttons. Okay. Here on the canvas, I have two additional buttons. One is the home screen, which will take the camera directly to a home screen location. You can take the camera even up and down. It's very convenient when you do three-dimensional setups. And there is the cube orientation on the lower left side. And you can change each and every corner here, and you would see that automatically jumps to a top view. If you want to do a side view, so you can do a side view as well. In this mount, which is a volume mount, you would be able to mount all kinds of optical elements that are not thin. So for example, let's take prisms, and let's take a right angle one. And so let's pick one. So you see automatically it would be mounted on this mount, and it would have the same capability as Kinematic Mount because it has those rods. We also have rectangular mount. By the way, this mount can hold rectangular. We do have two additional buttons at the below section of the toolbar on the right side. One of them is duplicate, copy, and the other one is delete. So let's duplicate this and let's delete this element. and just pick up a rectangular element, because this mount can carry a rectangular element as well. And we have some other mounts here that can carry them as well. A few words about the 3D optics optomechanics, because it's extremely important for everyone that wants to reduce the time that they build setup and reduce the time that they actually run alignment. The magic in 3D optics optomechanics is that they mount the optical element always in the center of the optical axis with respect to all the other elements. The way that we do it is we mount the optical element always from the back of the mount. So the surface of the optical element, you can see here, would always be mounted above the screw hole. So this is one key factor. Another key factor is that we are using a dowel pin mechanism. You would be able to see, let me, in the view section, eliminate the breadboard for a second and show you take another mount of ours, and I'll show you how the dowel pin mechanism looks like. So you would see here, we have a rainbow of dowel pin holes. Each one has a 22.5 jumps. So when you want to take a mount of ours, you just take back the breadboard. So when you take one of our mounts and you allocate it on the dowel pin grid, you will be able to move it just in the 22.5 jumps. These are the most common jumps. And you would always get the optical element in the center of the optical axis. Let's do here 45. And let's do here 45. And those would be right in the center of the optical axis from one another. We also allow to do this in 3D. Keep in mind that in the 3D optics mounts, we have, some of our mounts have discrete heights. And this height is similar to the grid here. So if in 3D optics you take a board and you can turn it to a wall, you would see in the software, you would get a wall which creates a very nice mounting location. So if I would take this, I would, just a second, change the orientation, you would see that it's automatically being mounted on top of this hole, so you can get very accurate mounting location when you work in 3D, and I'll show you some example later on. But let's now move to the interesting part, which is the simulation. So we have mounted here a few optical elements. So now I would like to run a simulation. So on the left side, I have the laser section. So in the laser section, we are working with a few companies. So we have here Cobalt, NKT, laser components, and there are two generic lasers. Like those they're not branded, and they can hold all the lasers characteristic that we have currently in the system. So the laser is similar to a mount. You just place it exactly where you need, specific in front of this mirror. On the right side, it will have different function. First, if you see, this is the name. If you want to see the spectrum here, this is the spectrum of that specific wavelength. You can change to different lasers that can hold this body. If you would pick up this laser that everyone knows, this one can hold just, it's a helium-neon laser. It can hold, just one spectrum, which is 633 nanometer. So I'm ready now to run the simulation. And we have here this blue button. Since I have put two lasers, so there is a small error. I would see two lasers here. I can run both of them or just one of them. So if you would see here, I don't have any optics. Actually, I do have, I'm sorry. So here in the off-axis parabolic mirror, you can see that this is coated with gold. So the color is changing. And this is exactly where you see the focus. I can take a spectrometer. Now I'm in spectrometer mode and explore this. I would get the spectrum. I can change here the range. And this is the Gaussian that I have selected for my source. And then here on the left side, I would see a little bit of change. That's it, due to the coating that we have on this mirror. To exit from the spectrometer mode, I would press the X and confirm. I also have here two other modes. One is the measurement mode. You can see that it's divided to groups. So I can go over here, select this mount, select this mount, and the third one, and I can see that I have a distance in inch. I can change it to metric, even though I'm in an imperial environment. So these are the distances between the center of the mount. I can take the mount and I can change it, and you will see that the distance would automatically be changed. And this is something very easy. I can add another group to this measurement, and I would have in a different color. This is yellow, this is orange, and I can do as many as I want. The optical distance I will show you later on when we'll have a different kind of a setup. So those are the tools that we have currently available here. Back to the source. I would like to take a detector. I have here a few detectors. The first one are screens. So this is a transparent screen. I will put one screen here. And then let's put here a camera. And let's rotate the camera. And let's put the camera here. And let's take this a little bit up, and we'll see if we can sorry. Let's see if we get hit in the camera. But the camera would function very similar to a screen. So I'll show you how the screen looks like. And let's run here this again. So if I press the screen or the camera, I would have on the right side a detector button. So if I would press it, you would see all the rays that got hit by this screen. Let's do zoom in. So I can pick and choose each and every one of them. I can get the spectrum. I can change the screen color. That would get me to my preference directly. In the detector image, let's pick up black because this is a yellow beam. So I can see this. Let's move it a little bit bigger. And I can do some measurement between two dots. If I want to see, pick one, and I can see what's the distance between those two dots. So this is the detector screen. And if you would press the camera, you would get the same thing. In this case, this camera didn't get hit by any ray, so there is no data to present. I didn't mention at the beginning, what we are running here as the simulation is a ray optics simulation. So this is the physical engine that is running in the background. Back to the laser, you would see more function for the laser. One is the beam. So you can do a beam shape profile. So you can do a circular profile. We can do matrix illumination and one ray. So circular profile, we can define the diameter. So here, let's do a 4-inch. Let's do 25 rays. And 5 circles. And if I would run the simulation again for this laser, you would see now that it's a little bit bigger. And let's change it back to 2. And let's turn this into 15, just for the sake of the simulation. By the way, for your information, the simulation is utilizing your personal computer resources, so CPU and memory. So if you have a weak computer, so make sure that you don't use a lot of rays in the simulation here. You can change it to be a point source and just define the degrees of the point source, and you would see here that now it becomes a point source as opposed to a circular profile. If I would go a little bit down to the laser mask, so we can change and decide which mask we want to apply to this laser. So when we apply a mask, automatically it would become a point source. And each and every dot in the mask would be a single point source. You would see now that the simulation will take a little bit more time to accomplish. So instead of 5 seconds, it would take, say, 30 or 45 seconds. So again, it depends on the local resources that currently you have on your computer. We recommend to use either Chrome or Edge browsers. We found out that their Java engine is the best ones in terms of crunching the physical numbers. So let's press stop here. So if you remember, we did the mask. So if now I press the screen and the detector, I would see the 3D. And each and every dot of the 3D is a point source by itself. So this is something that we prepare for imaging, which we do not support right now. But the imaging would come, I would say, in the next 2 months. So that was a mask. And let's change it to no mask. So this is about lasers. And we mentioned cameras as well. Keep in mind that you have here one isolator that you can use, and 2 modulators that currently are functioned just as CAD models, and they don't function similar to all the optics that I've showed you. So we have that. So once I'm ready with my design and I want to save it, so first option is to go here and do test or whatever, demo test, and do save. This design will be saved in your personal cloud environment. So if you do now new, just a second. So you see new is not working, but let's start from the beginning, or just refresh the page and go again. So if now I go to File, Open, I would find my demo test here, and I can upload it, the demo test directly to my screen to find everything here. Another option is to export. When you do export, you can write some comments. If this setup is associated with a publication, so you can add the link or whatever, or skip this. So now you have downloaded an OPT file. This is a proprietary format of ours, and you can send it to your friends or colleagues. And now you can import. You can import that specific file from your local computer, and you would get the same thing as you imported from the cloud environment. Another button here is the Generate Bill of Material. You can export a PDF or a CSV. When you open this, you would find a few sections here. Each and every section has You would find the name. Here in the optics session, you find this one is from Thorlab. If you remember, we customized one of the optics, so you would find all of the parameters here, and this is customized. This is perfect, so you don't have any kind of element like this in the world, so perfect, so it's 3D optics. You cannot buy this, just for the sake of the simulation. Okay, so you have this in terms of the simulation tool. I want to show you a few more tricks and tools that I believe you would be impressed. So I'm jumping to two setups that I already did before this class. So this is, you can see, this is an optical tweezer. So the optical tweezer, you would see that it's using our optomechanics, 3D optics. This person has built a double wall because we want to get a rigid wall. This wall provided him a mounting location very accurately, and he used cage as well. So we did a mesh of 3D optics and other optomechanics, which we are compatible to all the other optomechanics. So this is as an example, and he ran simulation, and he can do all the alignment here even before he went to the lab and started building it. So this is one example. The other example that I wanted to share with you is this. It doesn't matter what this design is doing, but now I would like to share with you four tools which are amazing. The first one is a 2D sketch. So in the optical community, we are used to draw two-dimensional sketches, and we are providing you with a free tool that enables you to do that. So once you have your design and running a simulation, you can change the view to a top view and go to Tools, go to Optical Schematic Drawing, pick up the resolution of the JPEG that you would like to get. If you want to create a 4K resolution, again, it depends if you have enough memory on your computer. Okay, so now we have captured our screen, and now we can scribe out from this screen all the layers. So if we go here to Properties, we can either choose Show Optic Scheme. So you would see that automatically deleted all the optomechanics, and we have here just the optics and the rays. We can color the optics in silver, so it will be much nicer, and we can extract them to become bigger. We can show the labels. This is if we would like, if those would have labels, so you would see them automatically coming over here. We can show just the laser here. If we have something which is flat, we can change to turn it to thick. We can show instruments that we have done or not. Then we can have in the Add Note, we can either put some text here that we are accustomed to. So we can drag this. Let's put here, this is L1. And this, let's do M1. And post this. And we can create an appendix as well, L1, M1, create a border, do it a little bit bigger, post it, and we can post it here. We can do that. We can also have some icons as well here. So you would see here on the icon. So let's take like a camera and post it, resize it, and put it here. And you can use it and then export a PDF, and you would get that specific PDF, which you cannot see right now because this is a different screen, but you would get a PDF file of that specific capture that you have done. And you can repeat it. So this is one tool that I wanted to share with you. The other one that I wanted to share is the material information. You can go and find all of the material information that you have on other website here in this calculator as well. So you can pick up different materials, and you can get all the information on those materials in this calculator as well. Next, we would have an EFL calculator. You can find EFL calculator in some vendors' website, but in our website, it's a little bit more advanced. You can calculate the EFL of the lenses, and you can see the result here in real time by capturing R1 and R2. You can change here the EFL. You can see how it's going to affect the lens, and you can see how it's going to affect specifically R1 or R2. This applies to all the 4 different types of lenses. So let's change it to convex, and let's do the opposite. Let's take the EFL and let's change the R1 and R2 and find out what would be the EFL. So if we go here and change this to 50, you would see here how the curvature becomes more flat. Let's do 100. And you can play with this, and you can see that the EFL is changing. It's very, very nice to work with it, as well as you can work with the refractive index and change the parameters here and find out the result. Another tool that is one that it is now free, but later on this year it would become part of our premium package, but now you can use it. This is the Filter Finder tool. So this is an amazing tool that we have released a week ago. What we have done here, since now we have data from about, I would say, 6 different vendors that have filter catalogs, and we provide a correlation for all of them in a single shot. So here you need to define the type of the filter that you are working with. So let's take bandpass, and you need to define the region of interest, and then you need to define the number of matches that you would like to get from this query. In the filter region, you would need to define what's the filter region that you are looking for. Let's define 500 to 530. The filter region must be inside the region of interest. And then you need to define the height. Let's do 0.9. This is between 0 to 1. And then do filter search. What you would get here is in black, you would see what we have asked for. And you would see here in the results and what's the correlation. I'm just moving this so it will not bug us. So it's 95.44 correlation to our request. This is the Omega filter. And then they have another one with 93.31. And Shamrock has 90.70. And if you want to see what are the, we call them pass band errors and the stop band error, you can highlight the information here. So let's, again, don't show this. And those links are linkable. So if you press this one, it will jump directly to the vendor's page and see exactly the filter that you have requested. So again, this tool is now free for you to use. Specifically, this tool in the future would become part of our premium package. So I think we have 10 more minutes. So I would stop here and open for a Q&A if the forum has one.
Gil, thank you very much. Can you see the Q&A?
Where can I see the Q&A? Ah, I see. Okay, yeah, I can see this. Okay, so I got a question from Igal. Is there a possibility to add polarization optics element, polarizers, etc.? So currently, we do not support polarization for the simulation. but this is something that we have been working for the past 4 weeks, and I guess it will be released. I don't want to say in the next 4 weeks, but definitely in the next 8 weeks, you will have polarization capabilities and the optics associated with polarization. And again, another question from Eagle, is there a possibility to add custom-made optics, namely something? Okay, so I would take this question and I would add, is there a possibility to add even customized mechanical components? So currently, the answer for both of them is no. But again, this is something that we got already from other users, and we are working on that. So in the next month, we are going to release a version with the ability to upload customized mechanical components. Following that, there will be a version with uploading customized optics, including coding files.
And how, in what way the people can get this simulation tool?
So again, so I started with that, and I will show you again how you can get that. So the tool is free, and it's always going to be free by its basic version. All you need to do is go to 3D Optics homepage. This is where you have all of our products, and go to, you see here the blue button above, and here you would be able to register for the tool and get access to the tool. So this is going to the tool. If we are here in this page, I would like to show you a few more things. So in the software tab, there are optical design and apparatus design that we have provided for you, and this is just the beginning. So it's like a repository of designs that are already working and verified. So for example, this is a prism compressor. So you can pick this one, download an OPT file, go directly to the software, and import that OPT file, and you would have a design that you can play with, change, modify, just for you. So it's very convenient. We just started with about 45, 50 designs, and we are going to add much more simulation, much more designs. And this is just one example of design. And there are some tutorials that in the software under help tutorials, if you didn't catch any of what I was saying. So here are a few sessions, very short, like up to 3 to 5 minutes each and every session that you can play. And there's some other stuff on our website as well. But let's go back to your questions.
So anybody wants to ask questions? If not, I would like to thank Gil for this very interesting lecture. And please update us with all of your updates. So maybe we'll organize webinars in the future to show the progress of this.
I think I got another question. Mitch is asking, so he was asking, it looks like you are handling cylindrical symmetry in the system. What about 3D system which do not have that symmetry? What do you mean? We don't have any problem to deal with this. Mitch, if you can open the mic and ask directly, I think that would be convenient. What do you mean by not symmetry? Because you can do non-symmetry in 3D, that it's not a problem to mount not in a symmetrical way.
What I meant was that you have lenses and so on which are, not circularly symmetric, right?
Right.
Now, I can't see how, at least right now, that it's trivial to do that.
So currently, the platform supports the traditional mount. So those mounts support, I believe, support just symmetric lenses. Maybe we can take this offline and you can explain exactly what you need. And by the way, we are open for feedback, and we added a lot of features. Like every 3 weeks, we're adding a new release. So Mitch, if you, I can write my email here for everyone, which is gilnoy@3doptics.com, and you can send me a question, and we can either take it offline and talk directly, and I can inquire about those specific questions. I get another question from Gidon. Any support in the future from nonlinear elements? So the answer is yes. Currently, we have one element, which is nonlinear optics. You would find it in the nonlinear optics section. It's a basic simulation for it. It's not the full-fledged nonlinear optics, but that is coming soon. We would start with something free. But later on, it would be a full-fledged nonlinear module that would be part of our premium. But right now, you have one element that simulates nonlinear. Okay.
Right, great. Thank you very much, Gil.
No problem. So just come to the tool and register, and good luck to everyone.
Thanks. Goodbye to everyone.